All right, this is Mr. Wyrick, and I'm coming to you today on May the 4th. So May the 4th be with you. Got my Darth Vader tie on. I forgot my tripod, so I'm not going to be able to show you my work, but I will post a key of the review, kind of going over some of these problems, and I'll talk my way through it as best I can. So question number one, you won a prize. All you have to do is pick up a slip of paper out of the bowl. What's written on it is your prize. One piece of paper has new car, 5 have iPhone 12 Pro Max, 10 have $25 gift card, and 24 have firm handshake. Complete the probability model using the table below for choosing one of these at random. I like fractions, so I'll just say the fraction. Let's see, 24 plus 1 would be 25, plus 10 would be 35, plus 5 would be 40. So there's 40 slips of paper in here. So the new car, the probability would be 1 out of 40. Not high. The iPhone, and whatever decimal that goes to, that would be the same as like the percentage. The iPhone 12 Pro Max, there's 5 of those, so 5 out of 40, which reduces to 1 out of 8, which is, I think, 12.5%. 10 have the $25 gift card. That's 10 out of 40, which is 1/4. That's 25%. And 24 out of 40, those are both divisible by 8. That's 3/5, which would be 60%. So 60% chance you're going to get the firm handshake. And it says fractions or decimals, so not 60%, 0.6. Yeah. Number 2, your dad gives you a candy bar each day after school. Each day he has the same 5. This one seems a little misleading, but it's really not. On the first day, you can pick any of the 5. On the second day, you can pick any of the 5. On the third day, you can pick any of the 5. If you want to go for that rad Twix with the caramel and the cookie crisp, and yeah, that's probably my choice. And then the Reese's because of the peanut butter, But there's 5 options each of those days. So this is actually letter C. Option C there, 5 times 5 times 5 times 5. Number 3, Frank needs to choose one letter randomly from each of the boxes below. What is the probability he chooses a Q from the left box and an F from the right box? When it's and, that means we have to multiply. This is compound probability. A Q from the left box, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 1 out of 9. And an F from the right box, there's 2 Fs. And again, there's 9 letters. So this would be 1 out of 9 times 2 out of 9. 1 times 2 is 2. 9 times 9 is 81. This is 2 in 81 probability. Question number 4, pick a number 1 through 20. Now do it again. Now do it a third time. You can repeat these numbers. So my guess of getting yours right is 1 out of 20, and then 1 out of 20, and then 1 out of 20. So if I'm like, well, you're obviously going to choose 7, 5, and 7, because we can have that repetition, we're just going to multiply these all the way across. 1 over 20 times 1 over 20 times 1 over 20. 20 times 20 times 20. I just do 2 times 2 times 2, so that's 2, 4, 8. And then there's 3 zeros. So I have a 1 in 8,000 chance of getting this right. Number 5 is kind of weird. And I'll have to go over it twice. And I'll make sure that if you're in class, you'll see it. If you're not in class, you might need to check the Zoom or something, the recording. In a raffle, a number is picked from 1 to 25. Another number is picked from 1 to 25. What is the probability that a 2 is drawn on the first pick or a 9 is drawn on the second pick? Answer in fraction form. Because you could pick a 2 first and a 9 second, those 2 events are not mutually exclusive. In other words, you're just supposed to get the 2 or the 9, not the 2 and the 9. So on this one, the probability of drawing the 2 is 1 out of 25. Very simple. The probability of drawing the 9 depends on if you're putting it back or not. It would either be 1 out of 25 or 1 out of 24, depending on if you replace it or not. And again, the work that's on this should reflect it. And then you would need to subtract the probability of getting both of them, which would be, if you're putting it back, it'd be 1 out of 25 times 1 out of 25. If you're not putting it back, it would be 1 out of 25 times 1 out of 24. Now, for those of you that asked me in class, about this one yesterday. I did the 1 in 25 times 1 in 24, so it came up to like 8% or 0.08, which I can't remember what that is as a fraction, even though it says answer in fraction form. So I'd have to go back and check that one, and I'll try to make sure the key reflects that, okay? For those of you that didn't ask about it, it could be either one of those. Just make sure there's going to be a question like this on the test, guaranteed. Make sure you check and see if it says it's replacing or it's not. If it puts it back, you have all 25. If it doesn't put it back, or however many, if it doesn't put it back, you're down 1, and it's important to remember that. Number 6, Mia is at Arby's and getting her drink. She decides to go crazy and mix Dr. Pepper, Sprite, and tea. Not a good combo. What is the sample space for the probability of any certain order? That certain order means we're going pretty specific on the order. This is going to be that first one. Dr. Pepper, Sprite, then tea. Dr. Pepper, tea, then Sprite. Sprite, then tea, then Dr. Pepper. Sprite, then Dr. Pepper, then tea. Tea, then Dr. Pepper, then Sprite. Tea, then Sprite, then Dr. Pepper. Okay, so that option A, which is it's going to be gross. If this was combination, like, you stir and you mix all the flavors in and whatever. If this is permutation, like it looks like it's supposed to be, you put those in that order, it'll probably affect the flavor of what you're getting out of the straw, which is going to be gross. Question number 7, which of the following scenarios describes independent events from disjoint sets? Disjoint sets means they don't overlap. The numbers 1 through 20 are placed in the hat. You pick one first, keep it out. Then your friend picks one. What's the probability of you picking 1 and your friend picking 2? Those are not independent events. Those are dependent because the first one's going to affect the second one. Freddie Mercury chooses 1 fruit out of 6 to take to the recording studio. He then picks 1 of 3 songs to practice singing. What's the probability he chooses an apple and the song Bicycle Race? These are independent. The fruit that he chooses will not affect his choice of song. And then C, James Earl Jones can sign autographs at Star Wars or stay home. Next day he can go to a screening of Coming to America and sign autographs or go to the park. These are independent events. They don't have overlap. So this would also be independent events. They would be disjoint. Letter D, rabbi, a priest, and a nun walk into a petting zoo. Sounds like a joke. Only one person is allowed to pet the velociraptor at a time. If randomly chosen, what are the odds the nun is picked first and then the rabbi? The first one affects the probability of the second. So those are dependent. This should be B and C. Number 8, complete the probability table given the outcomes that follow a uniform probability model. Use fractions. Since there are 4 things, each should be 1 out of the 4. It says use fractions. Each one should be 25%. They should add up to 100% or add up to 1 if they're fractions. If they were 3, they would all be 1 out of 3. If they were 8, they would all be 1 out of 8. If there's 750 of them, each would be 1 out of 750 so that they're all equal. That's what uniform probability means. Number 9, write your own scenario, which is in which probability is used for 2 independent events. Use your imagination. I roll a 20-sided die with my right hand, and I flip a coin with my left hand. I don't know. I randomly blindfold myself and flick a dart at a dartboard with my right hand, and with my left hand, I throw a paintball at a target with 20 numbers on it. Just something that they're not going to affect each other. Has to be independent. Number 10, Nathan has 4 quarters, 2 dimes, 5 nickels, 9 pennies in his pocket. 9, 10, 11, 12, 13, 14, 15, 20. So this is out of 20. If he grabs 8 random coins, he should expect about one of them to be a quarter. 4 quarters out of 20 would be 2 out of 10. So it would be 1 and some change. So probably not. It would probably be closer to, he should expect 2 if he's grabbing 8 random coins. Letter B, if he grabs 1 random coin, there's a 5% chance it will be a dime. 2 dimes out of 20 is 1 out of 10. So there's a 10% chance that it would be a dime if it follows the same statistical probability. If he grabs 8 random coins, he should expect about 5 of them to be pennies. 9 pennies out of 20 would be 4.5 out of 10. So this should probably be less than 5. And then if he grabs 4 random coins to take out at once, he should expect 1 of them to be a nickel. 5 out of 20 is 1 out of 4. So if the probability follows through, like, he should expect about 1 of them to be a nickel. Yeah, that one's just, it should be letter D, but it's just kind of following through on, you know, are they following the, not the experimental, the theoretical probability. You have this theoretical probability. Is the experiment going to match it? More than likely, but you have to look at it. Allison decides to take 3 different fruits with her to school today. She has 7 to pick from: grapes, strawberries, kiwi, blueberries, orange, peach, and a pear. How many different combinations of 3 fruits can she take? This is combinations, not permutations. So this would be 7C3. And I should just put that in Desmos. NCR 7, 3. So there's 35 ways that she could do that, which is good. 35 is good. And then number 12, tomorrow there's a 40% chance of rain. Also tomorrow there's a 40% chance of having a test you forgot about. What are the odds of tomorrow being a bad day, rain, and a forgotten test? So if it's 40% and 40%, this is compound probability. So we take 0.4 times 0.4, and we're going to get 0.16, which would be 16%. Okay, that should be it. I will get this video uploaded, and I will get a key posted on the assignment, and good luck today.